All right, basically what we'll do today is just cover section 8.2, dealing with equations, equal relations and equations, by the way. Also, I do need to mention that I will grade the homework set and your quizzes on tomorrow since the campus will be closed on tomorrow. All right. So in section 8.2, we're going to look at equal relations and equations. And in this section, we'll recognize properties of equality and equations. We'll solve equations using those properties of equations or properties of equality. And then we're going to take this a little bit further and solve word problems. That means we're going to translate word sentences into equations and solve them. All right, so first we'll look at relations that may have properties such as these three: reflexive, symmetric, or transitive. And here we can use a balance beam to illustrate those three properties, like the reflexive property of equality. That means if I have sum A equal to sum A, that means they're both equally balanced. Okay, like 6 equals 6. That would be an example of the reflexive property. Okay, because I have the same amount on the left side as I do on the right side. Okay. The next property is the symmetric property of equality, where if I have sum A equaling to sum B, then if I switch A and B around to get this, it's still going to be equal. A equals B is the same as B is equal to A. So like if we were to solve the equation, we get x equals 6, that's the same as saying 6 is equal to x. Okay. And then finally, this third property is called the transitive property of equality. That is this: if I have A is equal to sum B, and then B is going to be equal to sum C, then by that property, I can say that A will be equal to whatever C is. Okay. That's what the transitive property states. A is equal to B, and then I say B is equal to A. Well, since A is equal to B, I can substitute the A. Substitute B with A and say that A is equal to C. Okay. And that's just a summary of those three equals relations for the reflexive, symmetric, and transitive property of equality. All right, now on the next page, we're going to talk about equations. So here, the word equation has the same Latin root as equal, because if you look at the word equation, it does have pretty much the phrase equal in it. So in an equation, you have to have an equal sign in it. So here, that equal sign will indicate that the values of the expressions on both sides are equal. So when we solve an equation, you're trying to find the value of that variable that would make it a true statement. So to solve equations, we need these properties here. One for addition, and the other one is going to be for multiplication. So here, if I have any real numbers, A, B, and C, if A is equal to B, then I can add the same constant on both sides, and that constant can be either positive or negative. And it's still going to be a true statement. Or if I multiply both sides by some constant C, for A is equal to B, then A times C is going to be the same as B times C. Now, in this case here, if I have these two right here. Now, equality is not going to be affected if we substitute a number for its equal. And we call that the substitution property of equality. And here's some examples. If I have A plus B, and that's equal to C plus D, let's say D is equal to 5. I can substitute that D in this equation with 5 to get this. So A plus B will be equal to C plus 5. So here, the equality remains the same, even if we substitute. Also, A plus B is equal to C plus D. Let's say B is equal to E and D is equal to F. Well, this B is going to be replaced with the E, and the D can be replaced with F to get this. A plus E is equal to C plus F. So I still have equality on both sides, even with substitution. Okay. Next, you see the two properties for cancellation. They call them the cancellation properties of equality, and that's going to be this. It's just the inverse or the reverse of the addition property of equality and the multiplication property of equality. For this one, if I have real numbers A, B, and C, let's say if A plus C is equal to B plus C, then what's going to happen here, we can say that A is equal to B. And basically what we're doing is just subtracting both sides of the equation by whatever C is. Okay. And then we'll end up with A is equal to B. And then let's say C is not equal to 0 and you have real numbers A, B, and C. If we multiply A times C and that's equal to B times C, then we'll end up with A is equal to B. What's going to happen here is this. We're dividing both sides of this equation by the constant C. And you'll end up with A is equal to B. Okay. And the other property is the zero property of, well, product property. The zero product property, meaning if I multiply A and B, that's equal, and it's equal to 0, then what's going to happen here is then at least one of those factors, either A or B, must be equal to 0. And in this case, with the zero product property, either A is equal to 0 or B is equal to 0. And it could be both A and B could be equal to 0 because here we're using what they call the inclusive OR. It could be either A equals 0 or B is equal to 0, or it could be both A and B equaling to 0. Okay, so those are just some of the properties of equality that are used with solving equations. All right, first of all, are there any questions before we continue? Okay, now let's talk about solving equations with one variable. Okay, now here we use the balanced scale model to help students understand the basic concept of solving equations and inequalities. Also, equations can be explored using the balanced scale. Now, when you're dealing with inequalities, now keep in mind inequalities have either less than, greater than, less than or equal to, greater than or equal to, and rarely in some cases they're not equal to. Okay. What happens in inequalities, the scales tilt. Okay. So like in this case right here, let's say we had this scale right here. On the left side is 2 times 3, and on the right side will be 3 plus the quantity 2 times 2. So in this case here, we would have an inequality because if you multiply 2 times 3, you'll get 6. But on the right side, if you do 2 times 2, that will be 4. 4 plus 3 would be 7. And in this case, 7 is bigger than 6. So what's going to happen here on this scale, this side of the scale will go down because it's heavier. The heavier part would go down. The lighter part would go up because it's less than. Okay. Now, in this case right here, we would have an equality. Let's say we have 2 times 3 on the left side. That's equal to 6. But then let's say 1 plus 1 in parentheses, we do that first. That would be 2. 2 plus 4 is 6. Here 6 equals to 6. So that means this scale will balance because the amount on the left side will be the same as the amount on the right side. Okay. And actually, this is an illustration of the reflexive property of equality. And in this case right here, let's say I wanted to find some solutions for the variables that would keep the scale balanced. Like if I have 3 times some square is and on the right side 2 times some triangle. In this case, the answers is going to vary. Let's say that this square represents 2 and that triangle represents 3. Well, 3 times 2 will be 6 and 2 times 3 will be 6. Or we can say that the square will be 4 and the triangle will be 6. Well, 3 times 4 will be 12 and 2 times 6 is also 12. So here there are a few variety of answers where the left side and the right side does balance. Or another answer would be if this square was 6 and this triangle was 9. Here 3 times 6 is 18 and 2 times 9 is also 18. So in this case, here, those answers would vary. Okay. Now let's say here we want to solve this equation for x. So on the left side, you got 3x minus 14. The right side, you only have 1. Okay. And this is how we use these scales to balance the left side and the right side. Notice here, if we use the addition property of equality, here we're going to add 14 to both sides of this scale. And to do that, minus 14 and plus 14 is the same as adding 0. So you'll be left with just 3x, and then that's equal to 1 plus 14, which will be 15. And to solve for x, we're multiplying by 3. So we do the opposite of multiplying by 3, which is divide both sides by 3. So that means x is equal to 5. And that's using the cancellation property of equality. Okay. And since I'm on this right now, I do have another, I'm going to show you a website where the scales is an illustration of that's used for solving equations. And that is this right here. I don't know if you've heard about this before, but here's a website for hands-on equations. And what that is just a manipulative where students in grade school or in middle school can use blocks and then the scales to solve linear equations. Okay. And I think there's some parent materials and then here's some teacher materials. I'll click on that. Okay. Or they're just showing you this right here. And here are just some manipulatives here that can be used. Okay. And here's how they demonstrate the balance scale. And they use game pieces like just chess pieces. Okay, and I think the ones that are in blue represent the variables, and the white ones represent variables, and the blocks have numbers on them. Okay, so here, that's just something that can be used to help students learn algebra, especially in solving equations. Okay, and this was created by someone by the name of Henry Boyson. And if you're interested, if you want to know something more about this, I'll put up a link in Blackboard regarding that website for hands-on equations. Okay. So now let's go back to this. All right, let's look at some examples here. Here we're going to use those properties of equality to solve equations. And here we're going to be looking at just various types of linear equations, like 2x plus 3 is equal to x plus 21. 2x plus 3 is equal to x plus 21. Let's say I want to solve that equation for x. All right, so the first thing I need to do here, now notice with these linear equations, you may have variables on both sides of the equation. So the first thing you have to do there is try to get all the variables on one side of the equation and then move the constant terms over to the other side. So first we'll move the x's on one side, and I would prefer, and it would be best practice to move the variable that has the smallest coefficient over to the other side. That way you won't have to deal with negative numbers, okay? So I'm gonna move the x over to where the 2x is. All right, this is like adding x. So that means the opposite of that would be to subtract x on both sides. So if I get 2x minus 1x, that's just going to be x, and then plus 3, and that's equal to, here, adding and subtracting x is the same as adding 0. So x minus x, that would be gone. You're left with just 21. So you got x plus 3 is equal to 21. And then to get x by itself, you're adding 3. So the opposite of adding 3 would just be to subtract 3 on both sides. So here, adding and subtracting 3 is the same as adding 0. So you're left with x, and then 21 minus 3 would be 18. Okay, now that would be my proposed solution. So if you were asked to check to see if that solution satisfied this equation, what I have to do there is take your original equation and substitute it with your proposed solution. Substitute each x with the proposed solution. So here on the left side, I have 2 times x, which is 18, plus 3. And I want to know if that's equal to x, which is 18, plus 31. Sometimes they put a question mark above the equal sign to indicate, will this left side equal the right side after I finish checking? So here, if I do 2 times 18, that's 36, plus 3. Now I want to know if that's equal to, well, I can add 18 and 28, that would be 39. And if I add 36 and 3 together, I will get 39. So that means this solution, this does check. The left side does equal to the right side. So I can conclude x equals 18 is the solution to that linear equation. All right, any questions about problem number one or example number one? Okay. All right, number two. Here we got the equation 4x plus 8 is equal to 4 parentheses x plus 8. 4 plus 8 is equal to 4 parentheses x plus 8. And let's say I want to solve this equation for the variable x. Well, notice on the left side, I'm not going to be able to do anything but the 4 plus 8, 4x plus 8. So I'll bring that down. But the right side, I got 4 times the quantity x plus 8. So that means I'm going to need to use what they call the distributed property. That means I need to distribute the 4 over the x and the plus 8 through multiplication. So in this case here, 4 times x, that's going to be 4x, plus 4 times 8, 32. And then we're going to try to get all the x's on one side of this equation and all the variable terms on the right side. Well, I'm going to move the 4x up to where the 4x is, and I'm going to do that by subtracting 4x on both sides of this equation. Now, when I do that, 4x minus 4x, that's 0. I'm just left with 8. And that's equal to, again, 4x minus 4x. That's 0. I'm left with 32. Does 8 equal to 32? No. So here, this is a false statement. So when you solve an equation and you get something like this that's false, that means that this equation, this linear equation, will have no solution, meaning that there is no value of x that will satisfy that linear equation. Now, sometimes when you want to indicate that there's no solution, they use this symbol, a circle with the slash over it, which is actually the empty set. And that means that there's no value of x that will satisfy that linear equation. Okay. Any questions on example 2? Okay. Let's look at example 3. Let's say we got this. 7 times the quantity 3x plus 1. Plus 9 times the quantity 3x plus 1. And that's equal to 112. And here I want to solve this equation for x. Okay. Actually, there are 2 ways of solving this equation. There are 2 ways of solving this equation for x. One of them, of course, you can use the distributive property by distributing the 7 over the 3x and the plus 1, and also distributing the 9 over the 3x plus 1. So 7 times 3x, that'll be 21x plus 7 times 1, which is 7, plus 9 times 3x is 27x, plus 9 times 1, which will be 9. And that's equal to 112. Now, if we combine like terms, 21x and 27x will give me 48x plus 7 plus 9, that's 16. That's equal to 112. And now to solve this equation, I need to get 48x by itself. I'm adding 16, so the opposite of adding 16 would be to subtract 16 on both sides. So in this case here, adding and subtracting 16 is the same as adding 0. So this will leave me with 48x is equal to, what's 112 minus 16? 96. So 48x will be equal to 96. And then to solve for x, I'm multiplying by 48. So I need to divide both sides by 48. So x is equal to how much? 2. That's one way of solving this equation. Okay, and for the sake of time, I'm not going to do the check on this one. Now, here's the other way of solving this. Okay, I'm going to rewrite that equation again. 3x plus 1 is equal to 112. Okay. Now, notice 3x plus 1 and 3x plus 1 here. These are like terms. Would it be easy to add the coefficients of 3x plus 1? I can add 7 and 9 together and I'll get how much? 16. So it'll be 16 times 3x plus 1. And that's equal to 112. So in this case, if I take that 16 times 3x, that'll be 48x plus 16 times 1, 16. That's equal to 112, which is the same thing I have here, because from here, I can just go ahead and subtract 16 on both sides. And I'll be left with 48x on this side, and that's equal to 96. Divide both sides by 48. Again, x is equal to 2. So these are just two different ways of solving that equation here. If you see some type of pattern that you could easily use, then go ahead and use that. One way is just use a distributive property. The other way is to recognize that 3x plus 1 are considered to be like terms, and you can add the numbers that are in front of the parentheses. Any questions about example 3? All right, take a look at example 4. In this case, there are 5 parts to this problem. Here we want to solve each of the following if x is a real number, and if a real number solution does not exist, then of course we write no solution. Okay, starting with part A, we got x plus 2 is equal to 1 minus x. X plus 2 is equal to 1 minus x. So in this case here, I need to get the, well, what's the first thing I need to do here? Let's get the x's on one side. So if I want to move that minus x here, what I need to do here? Add x to both sides. So minus x and a plus x, that's 0. I'll be left with the 1 on this side. What's 1x plus another 1x? 2x. So I got 2x plus 2 is equal to 1. And then to get 2x by itself, what do I need to do? Subtract 2 on both sides. So I'll just have 2x, and that's equal to 1 minus 2. Negative 1. Yeah, it's okay to have negatives in here. And then 2x equals negative 1 means I need to do what? Divide by 2 on both sides. X has to be equal to, leave it as negative 1/2, and that would be the answer to that problem. X equal negative 1/2. All right, questions on part A. All right, part B. Let's say we got this 3/2 x. So now we got a fraction in front of this variable. Minus 3 equals x plus 4. Three halves x minus 3 is equal to x plus 4. Okay, so what would be the first thing I need to do here to solve this equation?
The first thing I did was I changed the fraction to a decimal, and we can just see it better.
Okay. So what would be 3/2 as a decimal? 1.5. Okay, so now, what will be the next thing I'll do? Subtract x from both sides. So I got 1.5x minus x, then minus 3 is equal to 4. I mean, x plus 4 minus x. Okay. And then the next step would be to, let's do 1.5x minus x, which is how much? 0.5x minus 3, and that's equal to 4 because x minus x is same as adding 0. And now to get 0.5x by itself, what would be the next thing I need to do? Add 3 to both sides. So the 0.5x is equal to 4 plus 3, which is 7. And then to solve for x will be the last step. Divide both sides by 0.5. So x will be how much? 14. I mean, there are many ways you can start that problem. Because of that 2 in the denominator, I would have multiplied every single term in that equation by 2 just to get rid of the fractions.
You can multiply the 3 by 2 to x by 2, 4 by 2.
Yeah, the 3/2 x I have to multiply by 2. The 3 would have to be multiplied by 2. The x would be multiplied by 2, and the 4 would be multiplied by 2.
And what do you do with the 3/2 again?
Well, it'll be multiplied by by 2, because this, here's what's going to happen. That 2 is like 2 over 1. And what's going to happen here is that these 2's divide out. I'll end up with 3x for that first term. The second term, I have to multiply by 2. This x will be multiplied by 2, and the 4 will be multiplied by 2. I mean, that's just me. All right, any other questions about part P? Okay, now let's take a look at part C, because that one has square roots in it. All right, so we got 5 parentheses 7x plus square root of 7 plus 3 parentheses 7x plus square root of 7 is equal to 8 times the square root of 7. Now, again, there was an example that I did earlier, and I did give a couple of ways of doing it. But if you look at this 7x plus square root of 7, and that 7x plus square root of 7, those are like terms there. They're alike in all kinds of ways. So I can add these numbers in front. 5 and 3 is how much? 8. So this would be 8 multiplied by 7x plus the square root of 7. And that's equal to 8 square root of 7. And then we're going to use the distributive property. So that means 8 times 7x, that's 56x. Now, when we do 8 times the square root of 7, we can't multiply the 8 times the 7 because the 7 is underneath the radical. So we just have to write it like this, plus 8 square root of 7. And then that's equal to 8 square root of 7. So now we can try to get x by itself, or 56x, I can get that by itself. We're multiplying it by 8 square root of 7. So that means, I mean, not multiplying, we're adding 8 square root of 7 to it. So the opposite of that would be to subtract. So I'm going to subtract 8 times the square root of 7 on both sides. Well, this is gone. I'm left with 56x. But what's 8 square root of 7 minus 8 square root of 7? 0. So if 56x is equal to 0, what must x have to be? Well, what's x going to, well, what's 0 divided by 56? Only one number, 0. So x equals 0 is the solution to that. I don't know if you can, well, it's going to be a linear equation, yeah. Questions on part C? Okay. Okay, let me erase part A and B. All right, so part D looks like this. 2 parentheses x minus 3 is equal to 4 parentheses x minus 3. All right, in this case here, I would go ahead and just use a distributive property, distribute the 2 of the x minus 3 on the left side and distribute the 4 of the x over the x minus 3. So 2 times x and 2 times the minus 3. Well, 2 times x will be 2x minus 2 times 3, which will be 6. And then 4, distribute the 4 of the x and the minus 3. 4 times x will be 4x minus 4 times 3 will be 12. Now I got variables on both sides of this equation, so what do I need to do here? What can I do here? I would rather subtract the 2x on both sides. So here, 2x minus 2x, that's 0. I'm left with a negative 6 equals 4x minus 2x. That's going to be 2x minus 12. And now to get 2x by itself, what do I need to do here? Add 6. Add, not 6, 12. Okay. So now I'm going to have 2x, and then negative 6 plus 12 will be positive 6. So here 2x is equal to 6, and I need to divide both sides by 2. X is equal to 3. And it's okay to write it like this: 3 is equal to x, because it is the same as saying x is equal to 3, according to the reflexive property of equality. 3 equals x is the same as x equal 3. Say 4. Questions on part D? Okay, finally, part E. Now, notice that equation is a little bit different from the other 4. Here we got x minus 3 quantity squared is equal to 36. X minus 3 quantity squared is equal to 36. Let's say I want to solve this equation. So what would you think would be the first thing I need to do here? I can't distribute. You, what? That I don't want to do because I got that 36 right here. I could do that if this was a 0 on the right side. What was that again? Square? What's the opposite of squaring? Anyone remember? Square root. So here I take the square root of x minus 3 quantity squared. And I also got to take a square root of 36. But what's missing? There's something missing here. Anytime I take the square root on both sides of an equation, I need something right here in front of it. There's a symbol that I need. No, almost. Right. Plus or minus. plus or minus. Anytime you take the square root on both sides of an equation, you need to include that plus or minus symbol. Because the value of x could be either positive or negative. All right, now let's simplify this. Square root of x minus 3, and we square it. The reason why we take the square root on this side is to get rid of that exponent of 2. Square root and the square are inverses. You're going to be left with what's underneath, what's inside the parentheses, x minus 3. And then that's going to be equal to plus or minus, what's the square root of 36? What number times itself gives you 36? 36. So I get x minus 3 is equal to plus or minus 6. So now, with that plus or minus, that means I do have 2 equations. The first equation is this: x minus 3 is equal to a positive 6. And then, or x minus 3 is equal to negative 6. So here you got 2 equations. Each equation you will solve for x. So for x minus 3 is equal to 6. What's the opposite of subtracting 3? Add 3 to both sides. So that means x is equal to 9. And then for x minus 3 is equal to negative 6. I'm still going to add 3 to both sides, but what's negative 6 plus 3? Negative 3. So with this equation, I have 2 solutions. One of them is x equals 9. The other one is x is equal to negative 3. And to begin with, if you look at that equation, that exponent of 2 tells me I have 2 solutions. Instead of the 1 solution that I have with the other equations. Okay? So that's what E is like, and how that equation is set up and how you have to solve it. All right, any questions about example 4? Okay. All right, so let's take a look at some application problems, or we call them word problems. Sometimes word problems give students a headache because mainly they don't know where to start with that problem. They probably can read it, but they don't understand what they want, what is being asked in the problem, and picking out the bits and pieces of information that's given to them that will help them solve the problem. So here we're going to use what they call the 4-step problem-solving process to solving word problems with algebraic thinking. You might have seen this before in Math 1. I know in Math 1 because George Polya, who is a Hungarian mathematician, came up with that 4-step procedure for solving problems. One of the first step is to understand the problem. That means we have to identify what is given and what is to be found. And then second, we need to come up with a plan or devise a plan. That means assign letters to the unknown quantities and try to translate the information in the problem into a model that involves equations. And then step number 3 is to carry out the plan, meaning we solve the equation or solve the inequality. And then the final step would be to look back. That means we take whatever answer we got, we interpret that and check the solution to determine if that answer satisfies that problem, or does the answer make sense to the original problem. So when you do the check, you don't use the equation itself, you use the wording of the problem to see if that answer make sense. Let's take a look at this example number 5. For a particular event, 634 tickets were sold for a total of $4,133. Let's say students paid $5 per ticket and non-students paid $8 per ticket. How many student tickets were sold? Okay. So already we know that 634 tickets were sold and the total was $4,133. And students paid $5 per ticket, non-students paid $8 per ticket. That we know. And then we're going to find out how many student tickets were sold. So let's start by letting X be the number of student tickets sold. I'll just let X be student tickets. Number of student tickets sold will be X. All right, so let's take some of this information that we have here. If X is going to be the number of student tickets, we also have non-students. There were 634 tickets were sold, and X is the number of student tickets. So I'm going to take the total number of student tickets, number of tickets, which is 634, subtract X from it. And whatever 634 minus X is, will represent the number of non-student tickets. Okay. So student tickets and non-student tickets total to be 634. If I let X be the number of student tickets, then the rest will have to be non-student tickets, which is 634 minus X. Okay, now let's try to translate that into an equation. Students paid $5 per ticket. X is the number of student tickets, so the cost is $5 per student ticket. So it'll be 5 times X. Then I'm going to add to it the cost for each non-student ticket. This is 634 minus X for non-student tickets. That needs to be multiplied by the cost of a non-student ticket. That's $8. So it'll be 8 times, in parentheses, 634 minus X. And that's going to give me a total cost of $4,133. So here's our equation. Okay. Now, is everyone with me on this? Okay. If not, speak now. Okay. Student tickets, $5. The non-student tickets, which is this expression, that's multiplied by $8. This will be the total cost. And that will be the equation that we will use to find out the number of student tickets. All right, so let's simplify, solve this equation. Bring down the 5X and then distribute the 8 over the 634 and the minus X. So in this case, 8 times 634 that would be 5,072. Minus 8 times X, that's 8X, is equal to 4,133. And then combine like terms. 5x minus 8x is how much? -3. So it'd be -3x plus 5,072 is equal to 4,133. And now to get -3x by itself, we're going to subtract. What will we subtract? The 5,072. So I got -3x is equal to let's see, -939. Okay. And then to solve this equation for x, we're multiplying by -3. So I need to divide both sides by -3. So x will be equal to 313. All right, now, let's see what x equal 313 means. Here we're letting x be the number of student tickets, so that means that x equals 313. That means 313 student tickets. Okay. And that would be our answer to that problem that we were looking for. How many student tickets were sold? In this case, x is equal to 313. Now, let's say they wanted the number of non-student tickets. Well, non-student tickets is represented by 634 minus x. So that means I have to do 634 minus the number of student tickets, which is 313. And that would be 321. And that 321 represents a number of non-student tickets. Okay. But in that problem, they just want the number of student tickets. So the answer there would be 313. This part is just an extra. If they were to ask that question, how many non-student tickets? Okay, any questions about example 5? All right, let me go to example 6, which is this. Let's say in the state of $533,000 is left to 3 siblings. The eldest receives 3 times as much as the youngest. The middle sibling receives $15,000 more than the youngest. How much did each receive? So we want to know how much did each sibling receive? Okay, so this is where our problem solving strategies are going to come in. All right, in this case here, we're going to identify what's given and what is needed to be found. All right, we know the eldest receives 3 times as much as the youngest. The middle receives $15,000 more than the youngest. We know nothing about the youngest child or the youngest sibling. So we're going to let x be the amount that the youngest received. X would be the amount that the youngest received. We also know something else. The middle sibling receives $15,000 more than the youngest. So 15,000 more than the youngest. The youngest is represented by x. So the x plus 15,000. That's the amount that the middle child received. And we know that the eldest receives 3 times as much as the youngest. Well, if X is represented by the youngest, then 3X or 3 times X would be the amount that the eldest child received. Okay. So all of that will add up to $533,000, which is the amount of the estate. So the amount that the youngest child received is X, plus the amount that the middle child received, that's X plus 15,000, plus the amount that the eldest received, that's 3X, which is going to be equal to 533,000. So here is our equation that we're going to solve for X. Okay, so now let's combine some like terms here. 1X plus another 1X plus 3X is how much? 5X. So this will be 5X plus 15,000, and that's equal to 533,000. And then I want to solve this equation for X. Well, let's get 5X by itself. Opposite of adding 15,000 would be to subtract 15,000 on both sides. So now I'll have 5X is equal to how much? 518,000. And to get X by itself, we divide both sides by 5. That would mean X is equal to how much? Okay. I'm putting a dollar sign here, so $103,600. Now we can't end this problem right here because it does say how much did each receive. We only know X is $103,600, which is represented by the amount that the youngest child received. So the youngest receives $103,600. Now we need to find out how much does the middle child receive. Well, the middle child is represented by X plus 15,000. So that means 103,600 plus 15,000 is how much? $118,600. That would be the amount that the middle child receives from that estate. And then we need to find out how much the eldest has received. That's represented by 3X, or 3 times 103,600. What would that amount be? Yeah, $310,800. That's the amount that the eldest has received. Now, of course, you can check to see if that answer makes sense. Well, if we add the amount that the youngest, the middle, and the eldest has received, we should get a total of 533,000. So if you add 103,600 to 118,600 to 310,800, the final amount of the estate should be $533,000. Okay. All right, any questions on example 6? Okay. And I'm afraid I'll have to pause it right here for section 8.2. I just got those last two I need to cover, and I'll be doing that on Monday. All right. So Monday, I'll just cover those last two problems in 8.2, and then we'll go into functions, which is section 8.3 on Monday. Okay.